In this video, we will learn about the structure of atoms. We'll learn about what atoms are composed of, protons, neutrons and electrons, and relate the size of atoms to everyday objects. Let me take you on a journey down to the atom. Imagine you have a lump of coal in your hand. It weighs about the same as a mobile phone. Inside that lump of coal, there are around 10 to the 25 carbon atoms. That's this many atoms. That's 10 million billion atoms. Now let's imagine we're going to cut the lump of coal into two equal pieces. Each piece would still contain an astronomical 5 million billion atoms. So you cut, and you cut, and you keep cutting. If you had the most amazing equipment on Earth, you'd eventually have 2 atoms. And with one final cut, you'd have a single atom. Now, take a guess at how many times you'd have to cut the coal in two to get just one atom. The answer is about 83 times. That's a lot of steps, so let's back up a little and look at what we would see along the way. At only 10 cuts, we're at the scale of a grain of rice, but that's still a lot of atoms. At 17 cuts, each piece of coal is the size of a pinhead. 10 more cuts, and each grain is the width of a human hair. As we go smaller and smaller, approaching halfway, we're on the scale of a single red blood cell. That's 40 cuts. 20 more cuts, and our microscopic dust looks like the nanoparticles of titanium dioxide you might find in sunscreen. At 70 cuts, we're back in the red blood cell, but this time at the scale of a single unit of hemoglobin. And finally, after 83 ever more precise cuts, we arrive at the carbon atom. The atom is the fundamental building block for chemicals. If we go any further, we get into the realm of particle physics, so we're going to stop there. And for this example, I've assumed that coal is 100% carbon, but there are other elements in there as well. So far, we've seen just how small atoms can be. But what exactly is an atom? There are many types of atom, but at a very basic level, they look the same. At the centre, we find a nucleus, and around the nucleus, we find a cloud of electrons. The nucleus is this tiny thing in the middle of the atom, and the electron cloud is this huge region of space around it where you can find electrons. We'll come to what electrons are in a little while. But exactly how small is the nucleus? If we divided the volume of the whole atom in two, just like we cut the coal, it would take 46 cuts to get to the scale of a nucleus. That's almost as many cuts as it takes to get from our lump of coal to the size of a red blood cell. We can also look at the nucleus in terms of its radius. It's actually difficult to say exactly how big an atom is because the cloud of electrons is a little bit fuzzy, but we can work out roughly how big an atom is based on how they fit together. If we do that, a carbon atom has a radius of about 70 picometers. A picometer is 10 to the minus 12 meters, which is 1,000th of a billionth of a meter. Now that's incredibly small, but the nucleus is much smaller. The radius of a carbon nucleus is about 3 times 10 to the minus 15 meters, or 3 femtometers. A femtometer is a millionth of a billionth of a meter. This means an atom is about 10,000 times wider than its nucleus, so the nucleus is incredibly small and the electrons occupy an incredibly large volume in comparison. Different types of atom do have different sizes of nuclei and different numbers of electrons, but the relationship between the size of the nuclei and the size of the electron cloud is similar. Our story doesn't end there. Inside the nucleus, we find 2 more types of particle: protons and neutrons. All you really need to know about these particles is they stick to each other very strongly, so the nucleus is very hard to break apart. The other thing we need to understand to appreciate these subatomic particles is a property called charge. Charge is a property of a particle which allows the particle to attract or repel other particles with charge. there are two types of charge a particle may have, positive charge or negative charge. And charged particles interact with one another depending on the type of charge they have. If we have two particles with positive charge, they'll repel one another. And if we have two particles with negative charge, they will also repel one another. However, if we have one particle which is positive and the other particle which is negative, they'll attract one another. So like charges repel and opposite charges attract. Protons have the positive type of charge, so they're positively charged, while electrons have the opposite type of charge, negative charge. Neutrons are relatively uninteresting in this regard. They don't have an overall charge, so we call them neutral. But we see lots of activity with protons and electrons. Protons repel protons, electrons repel electrons, and protons and electrons attract one another. Protons and neutrons stick together in the nucleus because of other forces that are beyond the scope of this video. If these forces for some reason stopped working, the nucleus would fly apart due to proton-proton repulsion. The next thing we have to deal with is how much charge protons and electrons have. What we do know from experiments is that protons and electrons have exactly the same size of charge. So if we have a proton and electron together, the combination acts as if it's got no charge at all. So we call this combination neutral. Physicists measured charge in coulombs, which is a human scale unit related to electrons passing through a wire at a certain rate. But chemists tend to use simpler numbers. We tend to say that protons have a single unit of positive charge, so we say their charge is 1+. Electrons have exactly the same size of charge, simply negative, so electrons have a charge of 1-. Neutrons with no charge are said to have a charge of 0. Charge is just one property a particle can have, but particles can also have mass. If a particle has mass, it can feel the pull of gravity, so it can have a weight. Gravity is what holds us to the Earth. If we use kilograms, the mass of protons, neutrons and electrons gets a little silly, so we can use unified atomic mass units instead. One unified atomic mass unit is 1/12 of the mass of a carbon-12 atom with 6 protons, 6 neutrons and 6 electrons. A carbon atom like this has a mass of 12 unified atomic mass units. A single proton has a mass of about 1 unified atomic mass unit. And a neutron also has a mass of about 1 unified atomic mass unit. However, a single electron has a mass of only 0.00055 unified atomic mass units. To keep this simple, sometimes chemists write the relative mass of protons, neutrons and electrons. This comes out roughly to 1 to 1 to 1/1840. What this means is that it takes about 1,840 electrons to have the same mass as 1 proton or 1 neutron. This is why the mass of electrons is sometimes completely ignored by chemists. The protons and neutrons are just so much heavier. Let's take a step back again and look at the whole atom. We know that the nucleus contains protons and neutrons. Protons are positively charged, so the nucleus overall is also positively charged. The negatively charged electrons are therefore attracted to the positively charged nucleus via the electromagnetic force. There are reasons that electrons don't just stick directly to the nucleus, but they are beyond the scope of this video. But you can always rely on electrons being attracted to nuclei. Positively charged nucleus, negatively charged electrons. That's easy to remember. The other thing to remember is that when we talk about an atom, we assume that it's neutral overall, meaning that the number of protons in the nucleus is the same as the number of electrons in the electron cloud. The other thing to remember is where the mass is. We've already seen that the electrons are much, much lighter than protons or neutrons, and that the protons and neutrons are in the nucleus. So it should be obvious that most of the mass of an atom is because of the tiny, tiny nucleus. Now that we've looked over all this material, let's have some practice. Subatomic particles can have a charge. What is the charge of a proton? What is the charge of a neutron? What is the charge of an electron? Subatomic particles, generally speaking, are particles smaller than an atom, although there are some exceptions. But the only three that chemists generally worry about are protons, neutrons, and electrons. In the simplest picture of an atom, there are two parts, a nucleus at the very middle and a cloud of electrons around it. The nucleus contains protons and, most of the time, neutrons. What the question wants us to remember is what the charges of these particles are. Charge is a property of particles which allows them to attract or repel each other. There are two types of charge, positive and negative. If two particles have the same type of charge, they repel each other. But if they have opposite charges, they attract one another. The easiest thing to remember is that a nucleus has a positive charge, and the electrons that are attracted to the nucleus have a negative charge. Inside the nucleus, it's the protons that carry the positive charge, and it's the neutrons that are neutral. If you need help remembering which particles have which charge, think about negative electron, positive proton, and neutral neutron. But we're not quite done yet. We need to know the sizes of the charges, not just their signs. For a proton, we can think about a hydrogen ion. A hydrogen ion consists of a single proton, and it has a single positive charge. So hopefully that should remind you that the charge of a single proton is 1+. The charge of a neutron is easy to remember. If it has no charge, it has a charge of 0. And the charge of the electron is simply the same size as that of a proton, but with the other sign. So the charge of an electron is 1-. In the next question, we're going to look at how the charges of these particles affects how they interact. Like charges repel each other via the electromagnetic force. Which of the following pairs of subatomic particles repel each other in this way? A. Neutrons and electrons. B. Protons and neutrons. C. Neutrons and neutrons. D. Protons and protons. Or E. Protons and electrons. There are two types of charge, positive and negative charge. When we see the phrase like charges, it means positive and positive charges or negative and negative charges. Our job is to figure out which pair of subatomic particles will repel each other because they have the same charge. For that, we need to recall the charges of neutrons, electrons, and protons. Protons have a P at the beginning, so that should remind you that they're positively charged. Neutrons have most of the word neutral already in them, so that should remind you that they don't have a charge at all. And finally, electrons are negatively charged. It helps if you remember that protons and electrons have equal but opposite charges. Now for this question, we don't need to remember exactly how much charge protons and electrons have. All we need to know is whether they're positively charged, neutral, or negatively charged. Neutrons are neutral, electrons are negatively charged, and they won't interact via the electromagnetic force, so we definitely won't see them repel one another. Protons are positive, and as we've already seen, neutrons are neutral, therefore we shouldn't see any repulsion due to the electromagnetic force. Although other forces do help protons and neutrons bind together. And when we only have neutral particles, neutrons with neutrons, we definitely won't see any electromagnetic interactions. But we will see repulsion between protons and protons, since they're both positively charged. So we've found our answer, but let's check the last one just in case. Protons are positively charged, electrons are negatively charged. Opposite charges actually attract one another, so instead of repulsion, we would see protons and electrons attract. Therefore, out of the 5 pairs we've been given, the only pair where we would see repulsion due to the electromagnetic force would be protons and protons. Now that we've looked over some examples and had a look at all the points relevant to the subatomic particles and the structure of atoms, let's look at the key points. An atom is the combination of a dense, positively charged nucleus and enough electrons to make it neutral. A nucleus is the group of protons and neutrons at the middle of an atom or simple ion. Atoms are made of 3 types of subatomic particle, each with their own masses and charges. Protons have a charge of 1 plus and a relative mass of 1. Neutrons have a charge of 0 and a relative mass of 1. And electrons have a charge of 1 minus and a relative mass of 1 over 1840 thereabouts. And lastly, electrons have so little mass compared to protons and neutrons that it is sometimes completely ignored.